Hello, welcome to the Tuesday evening AquaStax hour with me, Long Steve. And breathe. Had a bit of a rushed afternoon today. Just been hammering away at the old keyboard, writing some documentation. Not code documentation, but sort of product documentation. And you kind of get a bit carried away with it, and you just sort of go and go and go. And my alarm went off on my phone. 10 minutes to live stream. It's like, oh no, quick, reboot my PC, reboot my Mac, do the stuff I normally do to set up for the live stream, make myself a cup of tea, which I overfilled, so I had to carry it very carefully up the stairs, and ready on the crack of 8 o'clock. Excellent. Right, now let's dive back into where we were last Thursday, I think it was. Start up, click edit. Right, yes, collision detection. We were doing collisions between things, and I was figuring out how best. Well, I say how best. I was figuring out. Just adjust my mic and my glasses here. Got a little over the ear thingy. There we go. I was figuring out a little framework to test my collision testing code by being able to move the mouse around and move a block on the screen and have it collide with something that was already in the grid. What's that? Oh, that's Safari. No, I don't use Safari for testing. I use Chrome, don't I? Launchpad, Chrome. There. I should put Chrome on my quick launch bar. Silly, really. So, here we are, yes. So one of the things I was doing, rather foolishly, was thinking that I had to worry about collision detection or point in object code in order to be able to move my mouse around and pick up something that was on the screen. So I wrote a bunch of code that did that, and then I hit the chicken and egg situation, whereby I can't collision test a point against a block until I've written the block collision testing routines. But what I realized, of course, is that all I have to do is click my mouse button and then instantly have the block appear underneath my mouse. Oh, hi, Unicoder1, good to see you. I was just commenting on the fact that the other week I was trying to figure out how to pick up an object on the screen, a block, with my mouse pointer, and I was using the mouse pointer position and trying to do collision testing code to see if it had collided with a block. But I'm actually using this bit of code to try and write my collision testing code, so the chicken and egg situation was that I couldn't do that very easily. Then, of course, it occurred to me that all I have to do is click the mouse button down and move the block to the mouse position, like I've done. And there it is. If I'm holding the mouse button down, it moves the block around, the falling block in my game code, around over the grid. And if I let go of it, my mouse moves around. It doesn't matter where the mouse pointer is. If I click there, the block instantly snaps to it. So that now I can move my block around. I can see which of the grid cells underneath my block are the ones that the code will use for collision testing. Nice and simple there. And then I got to write the one path down the collision testing code, which was the two squares colliding. So that bit's quite easy. Two squares colliding is simply whether or not you've already passed the boundary box collision testing routines up the top here. At the moment, nothing is, and then as I move it over the block, there it is, it goes purple, because the boundary testing is now triggered and has actually got into this point here. And if the bounding boxes have overlapped and you're at this point, then you have a collision because they're squares. So I can move this around, and you'll see if I move it over the collision at any point, it goes purple. So that's working well. Now I'm going to go and implement these additional methods, which I've borrowed from myself from 10 years ago, my 10-year-old code. And I probably don't need quite as much verbosity, and I'm pretty sure I don't need 3 methods because they're almost all exactly the same, but I will write them as I did back then and then try and figure out how they work. So let's just find my old routine. Hi, Nikirk, good to see you, or Nikirk. Sorry if I pronounced your name wrong there. Here we are, here's my old collision testing code, and these are the 3 functions I'm now going to try and borrow from my past self and rewrite them. But before I do that, I'm just going to do a little bit of tidying up. I noticed a couple of JS hint warnings going on when I started up my project. I've been ignoring those for the last couple of weeks. It's always a good idea to make sure you keep them under control. So we've got a block size is already defined in game.js here. Yeah, I use block size all over the place, so it's quite often already defined. I can just get rid of that. There's, we've got new block position is already defined. This is one I'm kind of dropping into different bits of code here for testing out all my collision testing, but I am going to try and keep JS hint happy because it does help me spot obvious errors. Sometimes collision is already defined. That's the next one. Where are we? We've got var collision there. I've got it up here as well, haven't I? So let's just lift that out, and for now I'll stick it up here. Lost track of my code. There we go. Right. And collision, where else was it? Here. Just use that. Right, so if I save that, hopefully it will reload game.js and there are no warnings. Right, what else was there? Grid.js, bounds is never used. Well, I'll get rid of it. Slope collision is defined but never used. That's the function. We're implementing this at the moment, so I will leave that in there for now. Then we have, save that. Then we have scale x and y is defined but never used. This is in my test node code. Now I don't really need to use this anymore. In fact, I don't even want it in my project, although I don't want to remove it from source control. I want to leave it in there because it was useful to do that. It might be used in the future. How do you tell JS hint to ignore? I think it's JS hint unused. Unused true? It could be unused true or unused false. I'm not sure which. Let's save that and see what happens. So test nodes reloaded, and it didn't give me a warning, so that's good. I'm not sure No, it's fine. Maybe it's just right. I'm just going to run this from the command line so it does the whole thing. This JS hint in here is running in my gulp task, which automatically reruns things whenever I save a file. But I just want to do it over the whole lot to make sure. Gulp JS hint. See what happens. Got that one. We've still got this one. It's defined but never used. 128. Am I on line 128? Yes. Maybe it's false. There we go. It must be false. So another one of those. Is that? Yeah, there's one there as well. I just remembered rewriting this. Well, remembered writing this code, and it uses two paths. It's got the one and the other. JS hint. That's probably shifting it up to the global level, isn't it? Does that make a difference? No. I might. I'm just going to stick that inside that function, and I'm also going to stick it inside here, although it doesn't seem to be making any difference. And then gulp.js hint. Right, everything's fine. So also, before I go too far, let's get rid of test node from my project. And it doesn't appear to be in my actual Slick Edit project anyway, which is fine. Good, right. And is everything still working? Yes, it is. Right. So now I want to go ahead and start implementing my next collision test. Collide square with triangle. So what I'm going to need first is to make one of these a triangle. So I've got handle two squares colliding. So the way this code works is it's got a moving object and a grid object. So the moving object is the thing I'm moving around. The grid object is the thing fixed in the grid. And if they're both squares, we know that because we've hit this point, the bounding box testing has succeeded. So there's a collision that's going to occur. And if we get to this point, then we know that one of them isn't a square. So we're going to have handle triangle collision. So it could be here we've got, if the moving object is a square, then we call collide square with triangle. If the grid object is a square, we call collide triangle with square. If we get here, we know we must have two triangles. So we collide triangle with triangle, right? So I'm going to start with this one. And let's see. So I renamed some of my variables as I was going. I got rid of the 8 because that was fixed point maths, and I'm not doing any of that this time around. Grid object, grid pos x, grid pos y, moving pos x, moving pos y. Okay. And I'm going to implement, I'm going to do it as a separate method for now. So, collide square with triangle, function. Let's borrow the parameters from my old code. Collide square with triangle, here we go. Now, remember doing this before. You don't need fixed triangle, triangle x, triangle y. I've been trying to, I know that I used the separating axis theorem logic to do these collision testing routines many years ago, and I've been trying to find some decent tutorial that tells me how to do it again so I could write it from scratch, but I haven't been able to get something that works, or at least something that I think I could follow within a reasonable amount of time. Hi Wilson2000, good to see you again. How are you doing? Hope you're well. Not sure if I saw you since the beginning of the new year yet. Hope you had a good Christmas and New Year. Right, anyway, where was I? Yes, so there's definitely some axis aligned bounding box stuff, separating axis theorems going on here, because we got dot products and things going on. But I can't remember exactly where this code logic came from. And I'm both lazy and curious. I'm lazy in that I don't want to re-implement it, and I'm curious as to try and figure out how it works. So I'm just going to borrow it from my past self and see if I can't get it working. But of course now I'm going to need the collide square with triangle function to actually have a triangle. Let's just see if we're still working here. So we're still working. Ooh, oh no, we're not. Oh, what broke? Console. Oh, it's not a self.collide square with triangle, not a function. Function. Oh, I've just implemented it there. Why is it not liking that? Did I type it wrong? Or have I done the old trick of forgetting to? Yes, haven't done the self. Right. Okay, now it's happy. Right. So I've got a square moving around, and it still collides, but I need to get the code to come down through this path here. So I need the moving object to be, so it's handle triangle. The moving object is a square, so I need the grid object to be a triangle. So let's quickly figure out where this setup occurs. I think it's down here, yes, mouse move with block. I don't know if you were around before, Wilson, but I created a sort of a configuration parameter which lets me switch on and off a bunch of test code. So if I turn that parameter off, I've got the game playing pretty much as it's so far coded, and we've got collision for squares going on here, which is quite nice. You can see things slot in. I can slot in the blocks like that. they overlap each other nicely. They don't, so what's not happening, of course, is triangles aren't colliding properly, so this will end up, oh no, that did collide. Maybe it's the other way around. Let's see if I can't do that. I think that's going to go past. Yeah, it does. It doesn't work. So I'm trying to do the triangle collision routines now. Also, I can rotate stuff around on the side of the screen, and I think I can do rotation outside. I can't quite do it there yet. It won't rotate against another block. But you can actually make some quite cool, cool patterns. And I can't slot things together yet, so I couldn't upside down. I couldn't slide that in, but it's looking pretty functional actually. Almost a game one could play. But so what I'm trying to do is now isolate these triangle collision routines, and I've just got this specific bit of code now which allows me to move a block around, test it against all possible points, and it changes color when it collides. So what I was doing was figuring out blocks to start with 2. It's just using 2 squares. So what I want to do is, and it's using block type 3, if I just have an array, then I can do blocks to start with length. And in here, blocks to start with chump. That ought to give me exactly the same thing. Excellent, right. And now I want a new block, just a temporary one, or a new tile, that will let me have a triangle in it. So here, tile 3, this is my single square. So I'm going to borrow this and make a tile 8. And it's going to be, well, it could be anything, couldn't it? What do I want to, I suppose, try to start with number 1. So we just need 0, 1. And back in here. So the moving one, I think, is going to be the second one. And I want the fixed, collide square with triangle. It's the moving, square is going to be the moving thing. So I want the triangle to be the first 8, wasn't it? Block 8. There it is. So there's a triangle on my grid, and I'm still moving the square around. And it's not triggering yet. Why is that? Oh, because it isn't doing anything. It's not actually returning a function yet. Sorry, not returning the collision at all. Right. If I just do, if I just return axis collision, it should. I'm going to pinch these and stick them up here for now. It's probably a bad idea, but it'll let me test it quick. Ah, oh, but it's returning all the time. Where's that? It should only get to this point if these boundary box checks are successful. If px and py. So it's basically if the distance between the, if the separation of the two objects in x and y is less than 0, then they're overlapping. If any one is greater than, greater than 0, 0 is less than px. Sorry, if they're negative. So if the penetration depth in x, yeah, if depth goes negative, then one is inside the other one in either direction. So if it's, that's going to be positive in the x so that will bail out. That one won't trigger. And the same with the other one if I did that. But it's... Hi Wilson, good to see you. I'm just trying to figure out... oh, hi Live Coding TV support, good to see you. Let's see, I reckon I might jump into the debugger at this point just to see what's going on. So it's coming in here all the time. 25 years of coding, yes, quite a lot of them. It's a little bit, is it 25 years since? I can't remember. I put 25 years on the Live Coding TV page, but I think it's not 25 years like professional coding. I started when I was when I was 18, when I went to university. So what does that make me now? That's close to 25 actually. I'm almost 43 now. Yeah. So, well, I guess professionally, it was more like 20 years because I spent 4 years at university. Yeah. What was it like coding 25 years ago? It was, it looked a bit like this actually. So if you can imagine a, not much information is on the internet. No, the internet did exist. When I was at university, Netscape web browser wasn't available in my first year, but I think in my second or third year, by the time it got to about 1992, something like that, you could use not Firefox, it was Mozilla, Netscape, or Mozilla as it was called before that, to surf the internet. Before that, it was just Telnet and FTP, and Gopher, an old protocol that allowed you to look up text documents. I used books. Have I got one of my old books here? Oh yeah, here's one. Compilers, Principles, Techniques and Tools. Don't know if you can see that. This is the Red Dragon book about writing compilers. Used this at university in, when was it written? 1986 this one comes from actually, so this was quite old even when I started university. Got a few other books up there too. Hi, Andre Momoy, good to see you. Yeah, I was just about to go projects, AquaStax. So I had a 32, it's not a 3270, that was IBM, a VT220 terminal. And let's just, you'd use have I got VI on here? VI main.js. Yeah, I got VI. There we go. Main.js. Stack Overflow contributed hugely. Yes, it absolutely did. These days, programming is not far from Googling and Stack Overflow, is it? That's what you can get. You can get so far. So one would literally write code like this on a text-based terminal until. Can I remember the commands for VI? Yeah, I can. At least now we've got. If we were lucky, we had access at our university to the Sun workstations, which had a graphical user interface. And then you could actually have multiple windows open at once. Anyway, where was I? Colliding objects. And I'm looking in. I'm trying to figure out why this bit of code here is. Oh, where's my browser on? Is triggering when it shouldn't. You've got grid object is 0. And moving object. Moving object is 49. That's my square. Grid object is 0. Oh, that's interesting. It should bail out if it's hitting 0. I expect, having borrowed this code from myself from 10 years ago, there was some expectation on the fact that it wasn't actually called if the thing in the grid was empty. At the moment it looks like it is being called. So basically if grid obj 0, then there's nothing to test against, so we should just return, which will be 0 at this point. The same thing about moving obj, but that should always be at least something. I won't worry about that for now. Now we're actually not causing those functions to be called until the actual blocks overlap. But what we want to happen here is that that overlap shouldn't be colliding, but it is. Only when it moves within the actual triangle area. So let's see. I'm in grid.js. I want to start implementing collide square with triangle, and let's see what I used to do. So triangle type. I could either borrow this line by line, or I could just give it all in one go. Here we go. Right. So with that, let's call this OX and OY. Triangle type is going to be something related to my triangles from here, isn't it? So we've got triangle type 1, 2, 3, and 4, and it's figuring out whether or not it's in the upper 4 bits or the lower 4 bits of the integer that's passed in. So where I use 0, 3, where am I going? So all these hex integers here, so 31 for example, so 3 and a 1. I've got 1 and 0. It's just normalizing that so it doesn't matter. So that's fine. Triangle sine x. So that's a little table of integers here. So we have that. Triangle sine x, triangle type -1 shifted up by 1. The shifted up by 1 is the same as times 2, so it's effectively going to be indexing this array by the triangle type with 0, with actually triangle type -1. So triangle type is 1, 2, 3, and 4. It's going to be 0, 1, 2, and 3, and then index that array. That's a complicated way of doing it, but it looks like we've got sine x and sine y. So if we've got the normal Cartesian coordinates, that's going to be positive x, positive y. This one's going to be positive x, negative y. We're going down. This one's going to be negative x, negative y. Yeah, negative x, negative y there. And the last one's going to be, starting from the bottom, positive x. No, hang on, we're starting from the actual origin of the triangle. Negative x, positive y. Right, okay. So that's just figuring out the triangle sine. And then we use 1 over square root of 2 multiplied by the sine. I presume that's just a constant, is it? 182. That's fixed point maths, but it looks like it uses that. I'll borrow that. What could that be? I mean, the square root of 2 is obviously the length of that hypotenuse of the triangle. 1 over the square root of 2, so it's going to be possibly looking at the normal. It might be the normal, it might be something else going on here. Let's see. One divided by that. Okay, triangle unit size 7. So that was half of the triangle unit size. I did that up here, didn't I? Here we are, half block size. That's what I called it. I might stick a few of these variables out here. Story of my my coding so far has been I'll refactor that later. I think I might have a t-shirt printed with I'll refactor that later. Done. So triangle, so sine x and y 1 over square root 2. Yes, okay. And this is going to be xw. So this is the half of the width, effectively. So or the width or height of the square that we're using, half block size. There's obviously some sort of optimization been going on here. It's not the general case of any type of triangle aligned with any type of triangle. It's definitely right-angled triangles in certain ways. So then we've got OX equals square x minus triangle sine x. So triangle sine x times half minus triangle x. Triangle gives us the coordinates of the innermost point on the AAB relative to the tile center. Okay. And then what we do is this mul FP would have been a fixed point multiply. So I can just do, so DP is obviously dot product. So it's going to be OX times triangle SX plus OY times triangle SY. If the dot product of OX, OY and SX, SY is negative, the corner is in the slope, and we need to project it out by the magnitude of the projection onto OX. Right, okay. I hope I'm speaking like I sound what I'm talking about. Past me obviously did. Future me is going to have to figure it out. So mul FP, we're not going to need that, but we have this. So we've got some arbitrary looking negatives in here. I guess they might need to be changed if things don't work, because do I have x and y? Yeah, I do. They're parameters passed in. Hopefully, if as I'm doing this I figure out how it works, then I'll describe it to you. Maybe in a future stream. So we've got the length. So this is, oh, okay. So this is a squared, isn't it? The square of the hypotenuse is equal to the sum of the squares of the opposite and the adjacent sides, is how I remembered good old Pythagoras' theorem. But it's the opposite, that squared, that side squared, plus that side squared is equal to that. So it looks like we're not bothering to do a square root, which we don't need to, because we're only testing whether one is less than the other. And if so, we're returning collisions along the axis or the slope. That's interesting. I might need to change my code that draws what the collision type is, because if a slope collisions occur, I want to know that. So let's see. So we're calling this client-square triangle, and this is coming back. I've left a few ints in here. I'll get rid of those. They're going to break. Other than that, it looks like it's pretty standard old code. Okay. See if it works. Nope. So aq.grid is not a constructor. What did I break? Ah, unexpected. Oh, I've left an int in there somewhere. There they are. Although I don't actually need it at the moment as well, I will put our friend self equals this in there. Right, unexpected token. Ah, okay. That's doing this. Oh, ICA2, good to see it. There we go, right. Excellent, right. It's now not crashing, and I can move my block around. Oh, it crashes when the collision is run. So where's it going wrong now? Square Y is not defined. Ah, okay. Square Y? So where did square Y come from? Square X, square Y? Ah, okay, that's one of the parameters. Right. Ah, I forgot to take the 8 off. So square X and square Y. So the assumption is we're colliding a square with a triangle. It's the triangle that's fixed. That's its definition. And that's X and Y. And then the square X and Y is the position of the square that we're moving around. Right, let's see what happens now. Oh, that's good. It doesn't collide there, but it does there. Excellent. So it looks like, yeah, it looks like it's working. Oh, yes. So as soon as the point hits the slope, there it is. It collides. I wonder if that is actually hitting the bit of code that determines that it is a slope collision as well. So there's axis and there's slope collision. Right. So let's. I don't want that one. I want. So that's the axis collisions. They're overlapping. But the slope collision occurs when it triggers the on the hypotenuse there, the slope. Excellent. Right. Well, that's actually doing what I want it to do, which is rather good. Let's try different triangles. So we've currently got a 1 triangle. What I want to do is have a type 2 triangle instead. So actually no, I've got to change it in grid, haven't I? Sorry, in tile. It's my definition for tile number 8. It's currently a 1. Actually, I could put it in there. It should still work. So if that block was falling down there, it would actually trigger the collision now. Excellent. Now the next triangle type we want is 2. So that's the triangle pointing the other way around. Yeah, looking good. And it's colliding there. Excellent. So this is this is obviously where the sine calculations come in. Where's that code gone? Here it is. These sines here end up getting multiplying the distances, so you end up with whether or not you're in the right part, the right quadrant of the triangle to get the right collision out of it. Excellent. So let's try 1, 2. Let's try 3. So if you're 24, Wilson, what is it you do at the moment? Are you a student, or have you just graduated? Do you have a job? Are you a programmer? Are you a aspiring programmer? Be interested to know. Maybe you're asleep at the moment, lulled by my dulcet tones, but that looks like it's working okay at the moment. Now there must be a way of manipulating these numbers so that they work properly with the additional triangle and triangle things that I've got. Excellent. One thing I'm going to do is just change the color of that indicator so that I know whether or not a slope or an axis collision is occurring. Let's see, where do we call this from then? So it comes out of here. Collide objects is called out of here. Right. So collision test. So if collision does not equal 0, if collision ORed with, oh now this is where I need, this should just work because these are global now, aren't they? collision test. Just going to see what color I've got at the moment for collision test. There it is, cc.color. That. How do I change? Actually, I can just call drawRect again, can't I? So that's axis collision. And we want slope collision. We'll have it blue. Actually, no, let's have it green. Ah, didn't work. I'm trying to be too clever. Forgot to define block size. It's funny, block size is defined almost everywhere, but I wonder if that's actually working. So the purple is axis collision, slope collision is, so yeah, slope collision should trigger there, but it's not. Let's just see what's going on with collision. Collision is 512, which is 1 shifted up by 8, so that says axis collision. So it's not returning slope collision at that point. It is returning it there though. Yeah, slope collision is 512. Axis collision is 256. Slope collision is 512. Oh, what am I doing? It's and. Forgotten how to do testing for bits. It's collision and axis collision does not equal 0. Or we'll set the bit. To test for it, you do the and together. There it is, so nice. So we've got axis collision, although funnily enough that's a point on a thing there, but yeah, okay. Actually, yeah, that's a different type of collision. So when the final game is working as it should, that should be classed as a point collision. But I think there's probably something else that works that out. We've got slope collision, which is that, which means it'll slide. We've got an axis collision, which is that, which means the block would sit on top. And then we've got a point collision, which is that, which means that the moving block should shatter. Anyway, I'll worry about that later. Okay, so it's actually doing something useful. So that's working now. Let's see if we can't. We've got 15 minutes. Let's see if we can't just copy and paste the additional functions I'm going to have. So we've got collide triangle with square. Now this is where See, I could go further and just copy and paste all these ones down, or I could try and figure out what the difference is between them and just factor them properly. So collide triangle with square. Let's see if I can split this. And see what the difference is. So collide. So down the bottom here we've got, actually I'll do it this way around. So at the top here we've got collide square with triangle. Down the bottom here we've got collide triangle with square. So the only difference, let's lose that for a second so I can see it behind my chat window. So what have we got? So the parameters are the same. Can I use file difference? Does this check? Can I compare? Oh, I don't want to compare files. I want to compare selections. Ooh, that would be rather good, wouldn't it? I could actually copy and paste these into two separate files and do a file compare. I don't suppose there's a edit, select, other, lowercase, compare. Now, if SlickEdit had a compare selection, that'd be rather cool, wouldn't it? It doesn't. We'll see if we get anywhere before running out of time by just staring at it with my eyes. So I've noted that the parameter name is different. So moving fixed triangle and moving triangle, but it's still, we still use the same type. We still get the sine x and y. We still get the OX and OY projecting into the block. We still use the dot product. And then we still use P is less than N. It's collision axis or slope. So they're identical. Those two functions are exactly the same. Why did I ever write them twice? So actually, I can call, where are we, grid. So I can just do the same thing again here. So we've got collision self collide triangle with square. So all we're doing is we're passing the triangle in as the fixed triangle or the moving triangle is what the parameter was called, wasn't it? Yeah. So we're just passing the triangle as the first parameter. So in this instance, I know that the grid object is the square, so the moving object, in which case is moving object, is, so that's testing moving object and passes grid object. This is grid object, and I know the moving object is the triangle in this case. So that will do that. So now let's test out that bit of code by tweaking these numbers. So we're going to have 3 in the grid, and I'm moving the triangle around. Okay, so if I move the triangle, ooh. That's interesting. So it does that. Ooh, look at that. That looks like maybe the sign is not quite working, or there's probably a, did I miss a plus or a minus somewhere in this different, in these two different functions? Full horizontal, split again, split horizontal. So this is collide square with triangle, and this is collide triangle with square. Is it a parameter that's moving around? So x and y is the thing that's moving. Hang on a minute, what's x and y? I'm confusing myself. Ah, that's the point. that we've worked out. Okay, yep. So 1 over square root 2, triangle sine x and y, yep. Definitely got minus minus, yeah. We've got plus ox triangle oy triangle. Whoop. Ah, somebody joined. I couldn't see who it was. Maybe they left. Ah, it was Sean Pye. Oh, there you are. There's subtle delays occur between my bot showing the little avatar and people appearing in the chat window. Anyway, I was just about to... So we're definitely doing minus mol fp triangle sx minus dp triangle sy minus dp len n. So they are identical, but it didn't quite work. So I don't quite know why. It's almost there. It looks like, see, that shouldn't work, but it is triggering it. And that should trigger it, but it's not until it hits the... So it looks like it's testing... It's actually testing a triangle that's the other way around, isn't it? It's testing a triangle that looks like that. Let me just tweak tile.js and let's go back to number 1. Yes, that bit's alright. That bit's alright. It's the other way. So is it a case of missing the... by passing the parameters in incorrectly? How do we do it here? So this was called here, wasn't it? So we've got moving obj, moving pos, and then grid and grid pos. I wonder if I've got it around the wrong way. Yeah, I need to switch moving pos x and y. I need to put them in the front, don't I? Then I need grid. At this instance, I think. Let's see what's going on there. Okay, that worked well. Oh yeah, look at that. So that's recognizing that slope collision because it's colliding with the slope, and those are fine. Those are fine. And it goes right the way over. Yeah, it gets a slope collision, doesn't it? So let's tweak the tile again. So 1, 2. Yep. Looks pretty sane to me. 1, 2, 3. Different triangle rotation. Yep. Excellent. So that won't touch until just overlaps. And then 4 is going to be the other one. So then we've passed. That'll land. That would slide off. Right. So the last one is triangle with triangle. So let's have a look back at my old code. I've got just over 5 minutes to go. So triangle with triangle. This one's more complicated. Okay, right. So I've definitely got a different function here, and it's using the different signs to determine the ways whether they're oriented. So they're going to be sliding across each other like that, or not, or they could be pointing at each other like that. Yeah, all sorts of things going on. I don't know if you can see my hands moving around there, trying to be triangles. It's pretty complicated, but my guess is pick the shorter of the 2 projection vectors, a quick copy and paste, and it might just work. So, grid. we go. So function. Now what am I doing? Collide triangle with triangle colon function. X8, Y8. Moving triangle. 8. X and Y. Then we've got fixed triangle. Fixed triangle X. Fixed triangle Y. So hopefully I can just replace most of these with var. Ditch the 8s. Right. The two triangles are oriented the opposite ways. We can test from the center. Else do something different. Then dot product. Just multiply plus there's probably some duplication here that could be fixed as well, I think. We're doing dp1. Welcome, Valonia. Good to see you. It's rather boring at the moment. I'm just tweaking some old code that was Java and turning it into JavaScript. Multiply. I'm too lazy to figure out how it actually worked and re-implement it properly. Or, I mean, there's no guarantee it would be better now. It would still be just as complicated to understand 10 years' time, I'm sure. Keep doing that. I keep hitting Control and arrow, and that shifts my desktop around. So that's that. Don't need the ints. Right, I'll return my collisions. Let's see. Now we can call self dot collide triangle with triangle. X8 py8. So we've got moving obj, moving pause. Let's just hide that way so I can see what I'm doing. Pause y, grid obj. And it's hiding behind the let's do that. Right. Now we need two triangles to collide against. So let's tweak this so it's 3 and 3. So that would be two triangles of the same type. Oh, no, they're squares. I need 8 and 8, don't I? 8 and 8. That's it. Right. Oh, it crashes. Not surprising. Triangle SX8 is undefined. Oh, I've forgotten to do a rejiggy. There we are. Nope. Still forgotten one. It's possible that JS hint is trying to tell me actually. There we go. We got some Y8s not defined. Where did that come from? There we are. And we should probably use exact equals in those. That's an old one. Right, fingers crossed now. Yay! Excellent. So there's definite axis collision. So this is the thing that's we're testing with is the moving object. So axis collision there, yep. Axis collision there. That's a slope collision. And that's a slope collision. Awesome. Right, let's try two different oriented triangles. Where am I going? I want tile. Oh, I'm going to need... Oh, I know what I can do. I can just rotate this one, can't I? Yeah, there we go. Right, I can rotate it. So that's a slope collision, yeah. Axis collision. That's going to be a slope collision, isn't it? Yep. Axis collision. Rotate it again. Oh, look, they're not going to collide. They can actually sit over each other perfectly. Yeah, and they collide with a slope collision, isn't it? Yes, it's actually in the slope. If it moves beyond the center point, it's actually a axis collision. Yeah. If I rotate that around there, that's going to go fine. Nice. Oh wait, it won't. Oh yes, it will do it inside there. If I sit that like that, so that's not colliding, and now it is. And now it's not. Wow, it looks like my old code works. It's a little difficult to understand, and probably optimized just for this specific case. But this particular function I think is called a lot, because what happens is you have a large cluster of blocks, and all the blocks are made of triangles, and all the points where they overlap, that collide is called, and it determines it. And if at any point you have a point collision, then it should break the block apart. But if you have any axis collision, so if at any point it collides like that, then the blocks aren't going to slide because they'll be locked in place nicely. But if you only have slope collisions, then the blocks can slide off each other like that. So that's definitely the slope collision is useful going forwards, and that's looking really good. I could actually try some different shaped blocks. Let's just go for that, shall we? While we're here, let's go for let's try 0 and is it 3, which is the square one. It's all purple. Oh, it's a single square one. So that's colliding there. Yeah, that's nice. So it's definitely fine all the way around it. Only when it goes in there does it collide. Can I collide bigger? I'm not sure whether the function is called in the right loop yet, or whether it's just making the assumption that a single. I know collide objects. It is called for everything that it needs to be called for, I think. And the results are ordered together, yeah, so those bits are set. So let's try a few more different block types. So let's have a 0. Oh, we can have a 0 and a 0. Ah, it's not doing it, is it? Why is that not? What's going on there? Whoa, some funky looking. Yeah, I have a feeling that it's only currently working given a single shaped moving block. Sorry, a moving block of a single grid square in size. So it can only be number 8 or number 3. No, that's the wrong way around. That's a 0 and that's an 8. Then that works okay. Yeah. And if I change tile number 8 to be 31, so square. Yeah, so it's definitely checking whatever's in the grid correctly. So it's colliding with the squares. There's an interesting one. Number 7, I think, is a good one to put in the grid, because that's 2 triangles. Oh no, what am I doing? I want 8 there, 7 in the grid. Let's comment that out. X, Y, where X is fixed, Y is moving. Cool. So Y is fixed, Y is moving. So let's try 1. Excellent. So, got a bunch more collision detection routines done. It's 5:09. I've got to go now because I have to be somewhere a bit later on. But that's what's going on there. Access collision is not defined. It's external. Doesn't matter. Right, I'm gonna stop there and go with that. I think because that's looking like it's all working. I will just put the 3. There we go. We'll just do that. And I'll comment the fact that this is a test tile. Let's see. There we go. We've got the triangle one going on, so we can just test out the different collision types. Awesome. Okay. Let's jump back to there. Yep. I'm going to commit that to GitHub now. Let's just wait for that to go. Drink a sip of tea while I'm at it. Perfect. And let's just do gulp. I need to Gulp, I need to make sure that my gulp task is finished before I kill Slickit. 1953. And then we can lose Slickit. And now I can leave you for the day and see you again on Thursday. So, next stream will be Thursday afternoon at 3 o'clock UK time. Thanks very much for watching today. Looks like everyone's gone to bed now. They've all gone home. Nobody left apart from me and my bot Tim. I will shut him down now so that he says goodbye. Right, cheerio everybody. Thanks for watching. That's goodbye from me and goodbye for Tim, and I shall see you soon.